Assalamu alaikum. Welcome back to School of Physics, Understand Universe. Today, in this lecture, we will discuss, as you can see, the Newtonian physics and classical physics, or we can say classical mechanics. So earlier, before that, we have dealt with the fundamental forces and force in general, I can say. So now onwards, we will discuss a kind of physics which deals with the microscopic world, especially, more specifically, with the microscopic world as well, but its domain, the physics which comes under the category of the Newtonian physics, its domain is actually the microscopic one, because in the microscopic, in the smaller world, in the smaller physical world, these laws which are given by the Newton, they actually fail. So we will be mainly dealing with the we can say the microscopic world, the physics of bigger world, the physics of bigger things. Earlier we discussed various topics, as you might, if you are already on my school or my channel, you might be well aware about the things like force, the fundamental forces. We have already discussed all kind of these things earlier. As we know, there are four kind of fundamental forces, four fundamental forces in the universe, which are actually the gravitational force, and there is electromagnetic force. Then comes our nuclear forces, which are of two kind, or that are the strong nuclear force and the weak nuclear force. Now today onwards, we will be specifically dealing with that portion of the physics which deals with the microscopic world, which comes under the category of the classical physics, which was actually in we can say fully understood on the basis of we can say on the physical level, which was made understood by Newton. Actually, he was the founding father of the modern physics. Actually, before him, it was Galileo Galilei who actually made a foundation of this classical physics, but the actual work which was done by in detail, it was Newton actually. So that's why he is referred to as the father of the modern physics, we can say. Although actually Galileo is treated as the father of modern physics, because Newton himself laid the foundation based upon the laws which was given by the Galileo Galilei. So that's why we can say the founding father of the modern physics is Galileo. So now onwards, you have to keep in mind that we will be dealing with the classical world, not the quantum, not the general relativity, not that stuff. Keep that very stuff aside. We will be dealing with those very concepts in the later lectures. So today onwards, for few lectures which are upcoming, we will be dealing with the classical mechanics. As you might be already known about the forces in the nature, which I have discussed earlier. Now, to keep anything, say for example, there is a body, say body A. To keep this body in motion, we know we need a force, because force is that very agent which causes any body in an motion. So there are two types of motion, we can say. For just understanding, we have motion. Motion means the moving bodies. We can see the moment, or the body which changes the position with respect to time, I can say. Okay, so any body which changes its position with respect to time is said to be in motion, and that very motion, the body which is set in motion, is actually the working agent behind that very motion is actually the force. Okay, so we have two kinds of motion here. we can say the uniform motion, and another thing we have non-uniform motion. And the causing agent behind both these is actually the force, but there is a major difference. This uniform motion, here the working agent we can say is force on the first place, but it is not compulsory that any body which is moving does need a force, because if a body is moving already, it no longer needs force. It will keep on moving. Okay, this is actually demonstrated by Galileo. We will talk to that in a bit later time. So actually, the uniform motion is said to be that very motion in which velocity is kept constant. So it deals with that very bodies which are possessing some velocity, and the velocity is not changing, no change in the velocity. So those very bodies in which the body is moving, but the velocity is not changing with time. So velocity is constant. So that very motion is called as the uniform. And in contrast, the bodies which have not a fixed velocity, those are said to be in non-uniform motion. So that means actually those bodies are having or possessing the acceleration. Okay, so that means accelerated bodies possess the non-uniform motion. Okay, so there are two types of motion. One is uniform, in which the velocity is kept constant. For example, this body, it's on the first place. If it is given the force will change its state. Okay, for example, it's at rest, it will come into motion. But as long as force is kept aside, we are not now applying the force upon the body, it will start moving with a uniform motion. And that uniform motion, if no change in its velocity takes place, that is said to be in the uniform motion. Similarly, if we continuously push this body, say Fa is first applied, then force B is applied, then force C is applied, that means we are continuously changing its velocity, we are continuously changing its state of motion. Okay, so that means the body is not possessing a uniform velocity or uniform motion. That means the body is possessing the accelerated motion, that is the non-uniform motion. Okay, but there comes a problem. For example, say we set this body here, a body A is there. We have to, now there was a problem in the early ages at the time of Aristotle. What they were thinking before Newton and before Galileo, there was a problem that there is a body. If it is set in motion, then do we need an external force to keep this very body in uniform motion? So there was a query, we can say there was a question. The question was, is an external force required to keep a body in uniform motion? For non-uniform motion, we know that if the body is accelerated, so there must be a force behind that. It is well understood. The body must possess acceleration, possessing acceleration must be governed by some force. So that is well understood, that we need a force to make a body accelerated. Okay, but in case of the uniform motion, there was a question at the time of Aristotle. He tried to answer it. that is an external force required to keep a body in moving, to keep a body in uniform motion. Say a body here, if it is applied force and it moves with a velocity, say v, and at some, say, time t, at time t plus 5 seconds, it is also possessing the same velocity, v. Aristotle was the first who tried to answer it. That is the Aristotelian theory of motion. So we will discuss that, whether we need external force to keep a body in uniform motion, because uniform here, you know that now. Acceleration here, no acceleration is possessed by the body. If it is moving with the velocity, if it's moving with a uniform motion, with a uniform velocity, that means there was a question that whether force is required behind that. Okay, but